So my wife has a question for you. So my wife wanted to know if it's my mannerisms or you just think I look like Goofy.
Well, I drew a picture and next class I'll bring it.
You drew a picture?
Yeah, I'm going to stay silent until I bring it up.
Okay. Okay.
And then I think that will be enough evidence for your wife.
Okay. All right. So it's a look.
It's a look.
I look like Goofy. Okay.
Respectfully though, sir.
Well, okay. I'm not sure respectfully diminishes it, but we'll see. We'll see. I want to see this picture now.
It's a really good try.
All right. We have a test on Wednesday, right? Okay, so remember exam. Let me see my own camera here. Where is it? Where is it? Right here. To right there. All right, so exam 3 is Wednesday. Right. I sent out a review via email. Everybody should have that. I said take a look at it. We'd start going over it today. All right. And don't know if I can finish it, but I'm going to go for it. All right. So are there any questions before I start? I'm going to try and see if I can do this whole thing in the hour, 15 minutes. I think I can do it. I think I can. All right. Here we go. Let me say one more thing. If you can do this review, if you're comfortable with this, you'll be okay on the test. There's going to be no surprises. I'm going to stick to this format. 10 questions, all right? You are also allowed to have a reference sheet, just like every other test we've had, front and back of a piece of paper, formulas, steps, procedures, no worked out problems, right? Okay. But make sure you bring your calculators because you need a calculator for the test, right? You have to do the e to different powers, things like that. So I will not have extra calculators to loan out. If worse comes to worse, across the hallway, they will let you check out a calculator, but you have to leave your ID, and it's going to just eat up your time, all right? So, all right, number 1. We are going to sketch a rational function. So number 1, sketch f of x equals 2x minus 8 over x squared minus 2x. Now please keep in mind that as I'm going through this review, I'm not presenting it as if we're learning it for the first time, right? So I'm going to start just going through the procedure, assuming that you kind of know what to do. If you have a question, I'm not telling you don't ask, but I may not expand on the ideas too much because of time. All right, so the first thing I'm going to do here, anyone remember? What's the first step for this? X-intercepts. How do we find the x-intercepts? Set numerator equal to 0. So I'm going to set 2x minus 8 equal to 0. I solve this for x, and I get x is 4. It's just a little linear equation. So I have one x-intercept. Step 2, we find the vertical asymptotes. We do that by setting the denominator equal to 0. And that means I set x squared minus 2x equal to 0. That's a little bit different in terms of solving. How do we solve that? Anyone know? You do GCF, right? So you always, if it's a linear equation, you just solve it, move things around, isolate the x. But if it's a quadratic equation, factor. If it doesn't factor, you might have to use quadratic formula, all right? But here it factors. I can pull the greatest common factor out, GCF. And once I have the x pulled out of both of those, I can set each of those equal to 0. You'll get 2 different answers, 0 and 2. The third step is to find the horizontal asymptote, or you might have more than one. And so to do that, this is the one where we have to compare the degree of the numerator and denominator. So the degree of the numerator here is 1. The degree of the denominator here is 2. So we have that the degree of the numerator is smaller than the degree of the denominator. And whenever that happens, y equals 0 is your horizontal asymptote. So you have to go back and look in your notes. There were 3 different cases. One where the numerator was smaller than the denominator, one where this one was bigger than that one, and one where they were the same. All right? Make sure you have those 3 cases written down on your cheat sheet because you need to know what to do, right? All right, so I've got that. The next step is a quick sketch of everything. Not a quick sketch, but I'm going to put all that information onto a graph. All right, so let me see. This is going to be a little weird. I'm going to draw the graph in blue. So I have an x-intercept, right, of 4. So I go out to 4, 1, 2, 3, 4. Put a dot, right? That's an x-intercept. And then I have 2 vertical asymptotes, one at 0 and one at 2. All right, the one at 2 I think is easy to put here. You just go, vertical asymptote is that vertical barrier, right? And then I have another one at 0, right? That's kind of hard to draw because I already have a solid line here for the x-axis. So since you don't have colors usually on a test, what I would do is this. Instead of trying to draw a dashed line on top of that, you can do like little sideways dashes like that. And that way you at least can see it's there. Okay? Yes? You can use colors, yes. Most people won't have them, but go ahead. All right, questions? So I've got my x-intercept down, I've got my verticals. I need my my horizontal asymptote. I'll do that in purple. That means y equals 0, that's up and down. At y equals 0, that's the same as the x-axis. Out here at the edges, I draw a dotted line. Only at the edges, right? Not all the way across. And I'm almost ready to start drawing the graph, but now I need what? Test points. Good. I did tell my wife that you're a good student. You're always, because she was a little bit upset. So she was like, I was like, she's a good student, right? No, bring the drawing. You already said it. No, you have to. You have to now. Don't y'all agree she should bring the drawing in? You've already mentioned it now. Yeah, we'll take a vote. We'll take a vote. All right.
I've seen it. It's
pretty dead on accurate.
It's okay.
No, it's not that it's a bad drawing. I'm saying that I see it.
All right.
It's not offensive.
So here we go. Test points. How many test points will I have? How many? 4, because I have 1, 2, 3. I have 1 x-intercept, 2 verticals, right? We don't talk about this when we talk about test points. We count how many of these we have. We have 3 of those. You always have 1 more test point. So you'll need something. Let's see. Here's my first vertical. I need something over here. How about -1? Something between these 2 verticals. How about 1? Something between this vertical and this x-intercept. How about 3? Notice how I left space there for you when I made the problem so that you could have nice numbers in there. I'll do the same on the test. I'll make sure that there are nice whole numbers that you can get to. All right, so those 4 test points are going to get plugged into the original function, and we're going to see if it turns out to be positive or negative. That's all we care about. So let me plug in -1. Then I'm going to plug in 1. Then I'm going to plug in 3. Then I'm going to plug in 5. This is the part on the test that might take you a few minutes to do, right? Because you have to be careful and plug the numbers in. Let me see. If I plug in -1 on top, what happens if I plug -1 in here? I get, careful, I have 2 times -1, that's -2, right? Then take away 8. You still have negative, right? So it's a negative on top. And on the bottom, -1 squared is 1. So I get 1 there, and then negative 2 times negative 1, that's positive 2. So you wind up getting a positive on the bottom, so this turns out to be negative. Negative over positive is negative. So at negative 1, I'm going to put a dot anywhere I want down here. It just needs to be down. That's all that matters. And then I have to do that for the rest of these points. Okay? So when I plug in 1, I'm not going to do the work, okay? I'm just going to tell you it's positive, then this one is negative, then this one is positive. Again, that's going to take you a little bit of time during the test. So they alternate here. So at 1, I'm positive. At 3, I'm negative. And at 5, I am positive, like that. Questions?
Wait, so you don't even want us to like fully draw it out?
No, we're not done drawing it. Yeah. No, we're going to draw it. We're done with the test points.
Okay.
Now we get to draw it. So always start at the leftmost point that we have, which is right here, and then think about what's going to happen if I draw it to the left. Well, I have the magnet, right? That magnet pulls it towards it, so it's going to get pulled like this, get closer and closer. And then to the right, I have the vertical barrier, right, which forces my graph to either go down or go up, but I can't go up, right, because I can't cross here. I can only cross right there. It's the only place I can cross. So that means it has to go down and look like this. And then I actually do have to pick up my pencil and go to the next point, which is here, and then to the left, what happens? Barrier, right? So it's got to go which way? Up, right? Can't go down, can't cross anywhere in here. So it's got to go up like this. And then what about to the right? Up again, right? There's a barrier, so I have to go up again. It's kind of weird, right? That's what it looks like. Then I go to this point, and I think about to the left, it's going to force me down. And then I'm going to connect the dot, like these three connect like that. This has to be forced to go down. And then to the right, I have to flatten out back towards the magnet. There we go, we're done. So this exam is going to be, what, 75 minutes long, right? Hour and 15 minutes, 75 minutes long. Hopefully you can finish this problem in the first, I don't know, 10, 15 minutes. You don't want to spend more than 10 or 15 minutes on this problem, right? Yes?
How many of those are going to be on the test?
Well, I would anticipate 2 of these, yeah. So I'm going to, did you get the review?
Yeah.
Okay, it's going to follow pretty much like this review. All right, next problem, number 2, is another sketch problem. This time we have x squared minus 36 over x squared minus 5x minus 24. So we're going to go through the same steps, aren't we? Same steps. Let's do that. All right, so we want the x-intercepts, we set the top to 0. So I did this on the review, I did this on purpose because I wanted to remind you, to be on the lookout for something like this. This is a what? How do we solve that? That is a what? What do you see? It's a difference of squares. Good. So you see here we got 2 things that are being squared, that being subtracted. So this factors, it's one of our special factoring techniques. This is plus 6 minus 6 equals 0. Does that look familiar to you? When you see that? Yeah?
If you just solve it and use the square root.
You could use, remember, plus or minus. Exactly. Yep. So now you set each of these equal to 0. And you get negative 6 and positive 6. 2 x-intercepts. Then we want to see where the denominator is 0 for our verticals. And again, that denominator is another quadratic, isn't it? That's another quadratic. So I need to see about if I can factor that. And the way that we factor this is using that method that we had earlier in this class, like that method right there. That look familiar? Yes? So we multiply the number in front, 1 times negative 24, we get negative 24 here, and then the number in the middle is negative 5. And can you think of two numbers that multiply to be negative 24 and add up to be negative 5? Negative 8 and positive 3. Again, we've gone through this before, right? So I'm going to go to the next step. That is the factored form of that quadratic. And now you set each of those factors equal to 0. And you get two answers, positive 8 and negative 3. We good? All right, horizontals. For horizontals, you look at the degree of the numerator and the degree of the denominator. And in this case, they're the same numbers, right? What do we do in the case that they're the same? You look at the leading coefficients of each of these. So you look at the number here, 1, and you look at the number here, and then what do you do with those numbers? Just kind of make a fraction out of them, right? Just do that number divided by that number. So 1 divided by 1 is 1. So you'd say y equals 1 over 1, which is 1. That's our horizontal asymptote. All right, start to draw things. Okay, x-intercepts, negative 6 and positive 6. These are actual dots on my x-axis. I have verticals at 8 and at negative 3. So at negative 3 and way out here at 8. Any questions there? Horizontal comes next, and look at the way I do the horizontal. It's at y equals 1, so I go up 1, right? Up 1, and I only draw this out here at the edges. Oops, at the edges only. There we go. How many test points will I have to have here? 2, so 4, 5, right? I'm going to need 5 test points. That's going to suck. All right, so here are my test points. How about something over here, negative 7. Here, negative, let's say 4. Do y'all remember in class why I told you why I put the x's here instead of... So they don't think that it's like the negative 6 and the positive 6, right? You don't want to confuse those as x-intercepts. How about here? I do not need one between here and here because that's the y-axis. That's not one of my x-intercepts or verticals. So between that vertical and that x-intercept, I need something. Anything I want in here. I can do 0, right? 0 would work. And then between here and here is 7. And somewhere out here, let's say 9. Now we plug all those test points into the original function. So I want to plug in, I think this is the part that's going to take the most time probably for you, is the plugging in. I could be wrong. You want to plug in negative 7. Hey, how about I make you a deal since you're here? How about I make you a deal that on the test, I promise you that these will just alternate in signs. So if you get the first one right, just know that the rest will just keep switching. Deal? Yes? Is that a good deal? So like all you have to do is get one of these, the first one. If it comes out positive, I'm promising you that the next one's negative, then positive, then negative, then positive, okay? If it comes out negative, then it's positive, negative, you know, just it'll switch. It doesn't always have to be like that, but I will make the problem so it does that, all right? Okay, so let's plug in negative 7. Let's just make sure we get that one right. I'm going to do it right here just so we can see. There's a short way and a long way to do this, but since I'm only asking you to do one, I'm just going to plug it in here. I have to do negative 7. I have to square it. I have to subtract 36. Then I have to do negative 7 and then square it. Then subtract 5 times negative 7. Then subtract 24. On the top, negative 7 squared is 49 minus 36. That's a positive number. And then on the bottom, I have 49 plus 35. Careful. Double negatives there. And then minus 24. The bottom is also positive when you add those numbers up. So you have positive divided by positive, which is positive. And now I'm telling you everything's going to keep switching, okay? So minus, plus, minus, plus. I'm telling you that's going to happen, all right? Okay, let's finish drawing this. At this negative 7, I need to put a point above, right? Now, I told you in class it doesn't matter if you put it here or here or here. It doesn't matter as long as it's above. So, I don't know. I'm just going to put it here, all right? Don't worry about the fact that it's above that dotted line. That does not matter. Then here, then I have this test point negative. This test point positive, somewhere up here. This test point negative. This test point, I'll put this one right there, just so you can kind of see the difference between this one and that one. Everyone got it? Okay, from the left one, it's got to go down to the magnet. Then connect the dot, and then the barrier forces this down. This dot to the left, barrier forces it up. Connect the dot, barrier forces me down. Here to the left, barrier forces me down. Which way? Up, right? I can't go down here. I'll cross the x-axis. I have to go up here. Ooh, well, not really. It's not. I didn't mean for it to turn back on itself like that. Like that. And then flatten out towards the horizontal. There you go. Remember, all of our graphs might look a little bit different, but we should all have the basic shape the same. Questions there? Okay, we're 20 minutes in, right? Let's continue. Third problem. Sketch f of x equals 1.35 to the x. Okay, this problem should take you less than 3 minutes to do. Well, maybe depends on how fast you are with your calculator. But all I'm asking you to do here is create a table. X, 1.35 raised to the x. Here we're all going to put negative 3, negative 2, negative 1, 0, 1, 2, and 3, right? We all agreed upon that a long time ago. And now you get your calculator out, which I finally brought mine today. And I'm going to do that into my calculator. So when I plug in negative 3, so I do 1.35 raised to negative 3 on my calculator, I get about 0.406. When I plug in negative 2, I get 0.5487. When I plug in negative 1, I get 0.741. I'm rounding there a little bit. Plug in 0, I get 1. When I plug in 1, I get 1.35. When I plug in 2, I get 1.823. And when I plug in 3, I get 2.46. So you make your table, right? Again, that might take you a little bit of time. But now I'm going to draw this. And you need to kind of know, bless you, that this is exponential growth or decay? That's right. So this base is bigger than 1, right? So because this number is bigger than 1, it's exponential growth. So that should tell you that this thing is going to look like, it's going to go like this, right? Like this. So it's going to flatten out over here and then grow. So we already know that we're plugging in 1, 2, and 3 for x. The only question is, how big do these numbers get? So you can see here the biggest number we have is 2.46, right? So let's make sure that our graph only goes up to, let's say, 3. And then just plot the points, and you're done. and connect. So when I go to plot these points, I always like to start with the easiest one, this one right here, 0, 1. That will be on every exponential graph. So 0, 1 is here. When I plug in 1, I'm 1.3. We're just getting close, right? It doesn't have to be perfect. When I plug in 2, 1.8. When I plug in 3, I'm almost up at 3. I don't know, 2.4, something like that. Not quite that high. And then to the left, I said, don't worry about the points themselves. Just make sure you show that it is asymptotically approaching that magnet. There we go. We're done. Okay? Questions here? Yes?
What was that word you just used?
Asymptotically approaching. Asymptotically approaching. Yeah, it just means that you're approaching, the graph is like getting closer to something without actually getting there. So that's called a horizontal asymptote over on that end. Asymptote. All right, let's look at the difference between that one and number 4 on the review. So number 4 asks you to sketch a log function instead, right? So number 4, I want you to sketch f of x equals log base 3 of x. Who remembers how to do this? You remember? Okay, what do? You make a table, right? What are you going to make a table of, though? So you don't do a log. What you do is you do 3 to the x. So because this base is 3, you're going to go 3 to the x. You're going to make a table just like we did over there. And then you're going to flip them, reverse them. All right? So this is -3, -2, -1, 0, 1, 2, 3. That's all the same. Then you plug in, 3 to the -3 on your calculator, 3 to the -2, and so on and so forth. You should get 1, 3, 9, 27. Are we good or not? You don't understand what I'm doing? At -3, we're at, this is 0.037, and then this one is 0.11, 1, and then I'm missing 1 here, 0.33, 0.333. All right, so this is not what I'm going to plot, right? I'm not plotting these. I'm plotting these reversed. So I'm actually plotting like this. I'm going to go 0.037, -3. And this one is 0.111, -2. And then this one is 0.33, -1. This one is the 0.10. This one is the 0.31. This is the 0.92. And finally, the 0.273. So I'm plotting those reversed. And that's because the logarithm is the inverse of the exponential function. So inverses undo or take things back to where they came from. So that's why we flip those. So here's my graph. So you kind of have to know what a log function looks like. Remember, for a log function, there's nothing to the left of the y-axis. It's either going to go like this, or it's going to go like this. Sorry, like this. And in this one, because the base is bigger than 1, we should expect it to do something like this. We should expect a vertical asymptote where our graph goes down like that. Look at our x values. Our x values. They start at 0.037. They go all the way out to 27, don't they? All the way out to 27. So let's just say that this is 30 out here. This would be 20. This would be 10, roughly. I always, again, like to start with this one. 1, 0. So go to the right 1, and don't go up or down. Just 1, 0 right there. The next point that I think is easy to graph is this one, 3, 1. Go to the right 3, up 1. How high are we going to go? What's the highest y value we get here? Y value. +3, right? So maybe count 1, 2, 3, and then it goes -1, -2, -3. So when we go to 3, we go up 1. When we go to 9, which is almost to 10, we go up to 2. And we go out to 27, which is way out here, we go up to 3. You'll see where all those points are coming from? Yeah. And then connect this with a nice curve like this. And then over here, don't worry about plotting the points. It's too hard to plot those decimals. Just know that you are asymptotically approaching the vertical asymptotic. There it is. Yes? All right, number 5. Let's keep moving. So number 5, you invest $3,000 for 7 years at 2.35%. How much interest is earned? Assume simple interest. So we're using the formula for number 5. We're using the shampoo formula, right? And in this particular problem, I am giving you that you put 3,000 in to start. That's your P, right? 3,000. E, your interest rate is 2.35%, so I convert that to a decimal, 0.235. Be real careful with that, right? That's the part that people mess up. They forget to convert the rate from a percentage to a decimal. So move that decimal point 2 places to the left. And then how much time? That was your rate. How much time are we leaving in here for? 7 years, so put a 7 there. We're going to multiply that. So I'm going to go 3,000 E. Let's go ahead and multiply. You could do this all typed into your calculator at one time. It depends on you. I'm not going to do that. I'm gonna just to show you, I'm going to take the 0.0235 times 7. So this becomes 0.1645. That's if you multiply those two together. And now I have to do this on my calculator, and then I'll multiply by 3,000. So 3,000 times, let me do that on my calculator. This number becomes 1.1788, and then times 3,000. $3,536.41. This is not our answer, right? This is how much money is left in the account. What did it ask for? How much interest was earned, right? So you started with 3,000, right? And it grew to this. So if you take this number and subtract the 3,000, that's how much interest you've earned. So the answer to number 5 is $536.41. In class, I never asked that question, right? In class, I never did. I always asked for just how much would be in there. I never asked for how much you actually earned. You earned this much. Question? Were you able to get that on your calculator? Did you try it?
I did. I didn't get the